Hello, everyone. How are you? How are your mood? And where are you? Great. Hi, teams from Malaysia. Great. So you can turn on your cameras and we will say hello, good morning, good evening to everyone. Oh, Lena on the northern side in Russia. Great background. Oh, hi, Alexey. Hi, Pavel. So guys, where is your videos? Are you here? How's sound? How's quality of sound? Is it okay? If it's okay, please write plus into Zoom chat. Yeah, Science Petersburg should to sleep in this early time. Oh, hi, teams from India. Great. Nice to see you guys. Yeah, perfect. So now I think we can start. Oh, hi, teams from Cameroon. Great. Perfect. Okay, so let me share my screen and I will tell you about our plan for today. In just a moment.
Good morning, everyone.
Good morning, guys. Great. Hey guys, while I running my presentation, you can write in the Zoom chat your local time. It's really interesting to know about your local time right now. Oh, Cameroon, 6 hours in morning. Oh, you are early people. Okay, guys, so I hope my presentation has shown on your screens.
Yes.
Okay, great. So, and now we are ready to start. So, welcome to our second day of our Agile Skills Aerial Robotics camp. Yesterday we have prepared the introduction material for you, and you have passed this and these lessons. So today we have prepared for you the really interesting and useful program. So let's go to know it. Yes, of course. First of all, introduction from each countries, from Azerbaijan, Barbados, Canada, China, Egypt, Ghana, India, Kazakhstan, Malaysia, Mongolia, Panama, Russia, Saudi Arabia, South Korea, Turkey, Thailand, United States, and really glad to see teams from Cameroon. Cameroon has joined us recently, and I welcome your team too. Okay, so today with you will be our organizing team, me as a chief expert and organizers. You can ask me all questions. So today our work will be with trainers, with Timofey, Nikita and Lena. And also our teams, Ilya, Tatiana, and Artur will support us during all time this camp. Okay, let's start. Our great morning routine. Let's take an amazing picture, our welcoming pictures with greetings. So please turn on your cameras. Great, great. Best hair, makeup, and smile. Okay, guys, don't hesitate to smile. Oh, I see background Ilya. Ilya, you are in the Kremlin, yeah?
Yeah, you know, Moscow. And all Muscovites are in Kremlin. Where else should they be?
Yeah, thank you. Great, 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 great views, of course. And the background of Nikita from St. Petersburg. And drones from Malaysia. Reiki, great background too. Okay, guys, you're creative. It's really great. So I think we can make a common photo. So maybe anyone wants to join us with the camera. Okay, you can join some later. So we have a three chance to make a great photo. Okay, chance number one. 3, 2, 1, smile. Great. So let me save it. Okay, so try again. The chance number 2, and 3, 2, 1, smile. Hey, great, great. Okay, and the last chance to take the best photo. Are you ready? Steady. 3, 2, 1, smile. Perfect. Perfect, guys. Great. Okay. Thank you. So now we will continue. And I start my presentation again. Okay, so I would like to remind you about our rules. Please follow and track your microphone status. Then please rename your name in the Zoom account because it allows us to identify you during the camp. And don't forget and don't hesitate to ask us any questions during our training camp into Zoom chat. Okay, so now we are ready to start our lessons. But before it, I would like to share with you our plan for today. So as you remember, today is the second day, and today we will work with color recognition using computer vision technologies on drone. So how it will be provided? So first of all, this is our briefing. Then we will check your homework. Homework will be checking in the Zoom breakout rooms. We will create it, and each group will be work with the trainer. So then their homework will be finished, and we start to learn color recognition lessons. It will be spent duration of this lesson 60 minutes. Then we will have a coffee break time and your favorite activity, mini game. We have prepared it for you too. Be ready to start mini game after the break time. After mini game, we will continue with working on the real drone. And finally, we provide briefing and homework. So this is our plan for today. Also, you can recognize the QR code and get the full daily program of the camp. Okay, some words about how we will check the homework and how we will work in the Zoom breakout rooms. So there are 3 breakout rooms and 1 main session. Main session, it's here. So this main session will be given for advanced advanced group, and you will work with Timofey. So other 3 breakout rooms. Breakout room number 1 for beginner 1. The trainer will be Elena Silverstova. Beginner number 2 will be supervised by Nikita Bogatov. And the final breakout rooms, small talks. So this is a room if you want to discuss something during our homework or other questions, or it doesn't matter what you want to discuss. Welcome to small talks. And also if you checked the homework and our trainers is accepted, you're welcome to small talks breakout room. So how to join to the breakout room? You can see on the control panel in the Zoom this sign. You can press on it and move to the breakout room. Now our breakout rooms are closed. I will open it soon. Just a moment. Yeah. So and when you will join to breakout room, you can try to press the recording. It will help you to watch your recording when the Zoom will be finished. And remember all comments when our trainer give you during the homework check-in. Also, you should to share your screen and run the code on your laptop, or you can work with the trainer on their laptop. And so don't lose the feedback from your trainer. It's really useful. So, and also I would like to notify you because we have only 20 minutes for checking your homework. And it is mean that if you have several problems or we cannot to solve it faster, we can come back to your homework when in the end of our day. Okay, guys, you can ask me, you can ask the questions. Now I try to open the breakout rooms. Just a moment, I will find this menu. Okay, so the breakout rooms was opened. So, and I think if you have any questions, you can ask us right now. But if you don't questions, so guys, our trainers, Timofey, Lena, Nikita, are you ready to start checking the homework? Ready? Sure. Great. Okay, so if you're ready and if you are ready, guys. So the question from Mikhail, do we need to start the virtual machine before screen demonstration? Your task, your homework task is to demonstrate how you to perform the autonomous flight into simulator or on a real drone. So we didn't check how you set up the virtual machine, how you install it, only the final result. And we will give you comments about it. Okay, so I think you can go to the breakout rooms. So I remember you that advanced can stay in the main session. Okay, into beginner one, we have several participants. Guys, do you have a problem with the breakout rooms? The breakout rooms was opened. You can move to the breakout rooms. So, and we will finish our checking the homework in 20 minutes.
Hello, Arti. How are you? How is your
Okay, guys, how are you? Are you ready to show your homework? Who's ready, you can write in chat or you can talk actually.
I'm starting a virtual machine. I can demonstrate my homework in a few minutes.
Okay, the first was Vladislav Sirashkin. You can start your screen. So the first, Vladislav, are you ready to show your homework?
Yeah, I don't see where can I start screen.
Там все могут экране. So there is a green button. Okay. Okay, thank you. I see you've done your job. Do you have any questions regarding this homework?
No.
Okay, thank you. Good job. You can stop your screen and we will see the next participant. The next was Alexei. Cool. Okay, Alexei, good job. Thank you for your homework. We can go to the next participant. Ricky does real. Ricky, are you ready?
Hello.
Yes, you can start your screen.
Okay. Actually, I did my homework inside another PC, so I will share my. But I already recorded my screen, so I will show the video. Is it okay?
Okay, yeah, okay.
Okay, because I did the simulation in another PC. So this I recorded the video for the homework.
So you use navigate, wait, and navigate target, right?
Yeah, yes, I use navigate wait and navigate target.
Yeah, that's a more advanced level. Good job. So did you program Clover before?
Clover, not yet, but I've used this simulation like a couple of times, and I've explored some coding in this simulation.
Okay, great, great homework. Thank you.
Okay,
Let's
but
go to
can I ask a question?
yes.
Uh, can I? I've already tried to turn the Clover like using your parameters. I changed to 90 degrees, but when it turn around, it will drop the attitude.
Oh, is it in simulator?
Yeah, in simulator. Maybe you
Well, we
can
can.
demonstrate after this how to do your command, how to your the drone.
Okay, I can discuss this after our today's session,
Yes.
and we will have some free time. And please remind me if I forget this. We can watch what's going on and figure out the problem.
All right.
Okay,
Okay,
thanks.
thank you.
Let's go to the next. Mikhail.
Maybe Gazebo has some bugs.
Check
I
the
will restart
terminal.
it.
Check the terminal. Is there any problems? Yeah, you have to restart.
Guys, I see in the advanced group we have many people, so you can join to beginner group 2. It's not dependent on your experience, but we have a free trainer, and Nikita will help you to solve your problem or comment your home task. So don't hesitate to join into beginner 2 group, and it will save your time.
Okay, great. Great job, Mikhail. Do you have any questions?
No.
Okay, thank you. We can go to the next participant. It's
Thank you.
Vitaly Fan. Okay, can I see your code? So can you show the quadrat function? Okay, x, y, x, y. Oh, so your square was like very thin. 1 meter and 1.4 meters. Okay, good job. You have done this function, and the homework is correct. Okay, let's go to the next participant. It's Soumya Darshan.
Yeah, yes. Can I share my screen?
You can share your screen.
Okay.
Yeah, good job. Can you show me your code?
Yes, sir.
Okay, so I see you changed LED color, which is also great. Thank you for your homework. And we can, I think it was the last one who wanted to show his homework. Is there anybody else who wants to? Please write if you want to show your homework. Okay, Philip, you can show me. You can show us. Thank you, Philip. It wasn't like a square, but it was a good path. So I think you can do square with this too. And if you show me again the code, I can try to figure out what is the shape you're flying. One.
Ну, у тебя разрешения, что ли, нет? Или в чем проблема? Потому что разрешение есть у всех, каждый может.
I start from the end of the past program when he landed.
Oh.
And in the beginning, he fly to the zero coordinate, and from that, he fly to the square.
Okay, thank you. Then we can, I think you were the last one who wanted to show the homework. Okay, I think we're ready then. Svetlana, we are ready. And oh, we are waiting for one more person to come, and we will check the homework. Before the person came, I remember there was a question from Reiki, or from whom was it? The question about losing altitude when you yaw. We can look at this and figure out what's going on. Reiki does real. If you're here, you can ask your question and show us the problem you have. Okay, Reiki. Yes, I can show you in the article how you can change the yaw. Let me show it. So basically, if you want to change your, look at the symbol of board article, and let's find navigate. And here in navigate, if you want to change yaw, first thing is the yaw is not in angles by default, it's in radians. So if you want to rotate 90 degrees, you need to paste 1/2 of pi, which is 1.57. And one more thing is, if you are standing on your if you're hovering in one position and you want just to yaw, the drone may lose altitude if you are using body frame ID, because this frame ID have some errors of positioning. And if you want to rotate on your place, you can just use navigate with frame ID, either Aruka map or navigate target or map. They will work fine. So they will not lose altitude. One more thing is that it may be in parameters of the flight controller. So I don't think I'm going to show it to you right now, but there are some. Yeah, yaw rate. The yaw rate here is 2. Let me find it. So it only works with yaw set to none. So if you want to use yaw rate, it's done like that. Yaw equals float none. And the drone will be rotating at constant speed, but it will not stop at a certain position until you have another navigate. So there is a question: can we see all the ID of the Aruka maps before? I don't really understand what do you want to see. If you just want to know which ID is where, you can take off and look it at the topic called Aruka Detect Debug, and this topic will show you the IDs of markers that are visible. So I just can tell you that this one is 0, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. The last one is 29. And if you take off, for example, Commander take off and open the browser, and if you go to the topic called Aruka Detect Debug or Aruka Map Debug, it's in localhost. You remember that? Image topics and Aruka Map Debug or Aruka Detect Debug. So here it shows all the IDs, but it's flying too high. We cannot really see the numbers here. I can clearly see the 29 here, which represents the last marker. And this is the marker of ID 200. There's also a website where you can generate Aruka marker images. This website is called let me type it. chev.me/arukogen. And here you can see all the markers with their numbers. So this is marker 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on. And you can save the file, you can print it. So if you want to create Aruka marker field yourself, you can use this website and generate Aruka markers. Yeah, I hope it helps. Okay, we are done, Svetlana. Okay, the other people are coming to the main room, and after everyone comes, we will continue with our program for today. And while we are waiting for the others, I can show you some features of the simulator. So you can service call /navigate spacebar tab, and here you can type all the parameters. So you can map. So yaw will be 0 for now, and altitude 1. Let's go. And look how we can rotate around. So I call the previous command with arrow up, and let's select yaw equals to 1.57, which is 1/2 of a pi, which is 90 degrees. And it turned and didn't really lose altitude. And from here on, we can, if we keep this value here, we can fly to other points without changing the yaw, but you need to always keep the value the same. If I forget about this and change it to 0, it will go back to its original direction. Yaw equals 0 and coordinates. So it will both fly and rotate. Okay. Svetlana says we are ready. I can continue with the presentation, right? Do you want to say a few words?
Yeah, just a moment. I will check my presentation too. Yeah, so I would like to share with you one slide. Just a moment. Okay, so guys, thanks for your homework. So it's really useful for you to fix your knowledge and upgrade your level. So please be ready to perform, to do the homework during the camp every day. So now we are ready to start the classes. So the topic of today is color recognition introduction. And so Timofey, welcome. I think you are ready, guys. If you're ready, please write plus into Zoom chat.
Or reaction.
Okay, thanks. Thanks. We will begin right now. Let me open my presentation and start. Okay, OpenCV in Clover. We will be using some basic OpenCV functions to work with colors, and we will find the range of a colorful object, so we can detect some objects on the image and find their coordinates and check if they are there or not. So if you're Russian, there is a great article by Alexey Rogachevsky. It's in Russian. It covers much more than I'm going to cover today. So we will share the presentation with you later. This is some information for you. First of all, let's understand what are color spaces. If you want to work with OpenCV, you basically work with images and the images are just matrices of colors. Each pixel has its color, and there are different color spaces. Some of them, just a few of them, are RGB and HSV. So RGB is the most well-known color space. You can find it everywhere. It's in the screen, in your phones, in your computers. This is how you actually see colors, because you have three different types of cells that detect color on your eye, and another type that detects lightness. So RGB is red, green, blue. You can represent it as a cube, and this cube will, and each point of this cube is a unique color. For example, white color is the closest corner of this cube to us, the closest point, and the black is the opposite of that. You cannot see it on this image, but it's back there. Green contains mostly green without any blue and red. So if you add some blue to green, you will get this color. This is cyan. If you add red to it, so if you add blue, green, and red together, you will get white. But this color space is not very useful for detecting colors because, well, if you want to set a range of colors in each of the RGB values, it will be difficult for you to find the correct range, and the range will contain a lot of colors that you do not need to put into your recognition. The more useful color space is HSV, which represents hue, saturation, and value. This looks like a cylinder, and hue is the rotation of the cylinder. Saturation is like how much color there is. Zero saturation represents only black, gray, and white colors, and the highest saturations means that the color is the opposite of gray, and the value is just the how bright the color is. So RGB, as I said, has red, green, blue, and usually each component's range is from 0 to 255. So if you code a color, it is most probably R will be something between 0 and 255, and all the other color components will be within this range. But in OpenCV, the default color space is BGR, which is just blue, green, red, same values range. And you can just, the order is different. So the first is blue, then green, then red. And HSV range is a little bit different because hue is basically, well, in many other systems, not OpenCV, hue is in degrees. So it's 360 degrees of hue. But the number 360 will not fit into 1 byte. And because 1 byte has just 256 values. And this is why it was decided to think of, we will have the values, and we have the value range from 0 to 179. You can multiply it by 2 and you will get the degrees value of hue if you want to. And in many, if you just go and type HSV online, you will find that H will be in, let's see, the hue will go from 0 to 360 almost, well, 259, and if you go to 360, it will change to 0. And if you want to export this color to OpenCV, you need to know that if this color hue is 231, you need to divide it by 2, and you will get something around 115 or 60. Okay, let's go to the next slide. Image has coordinates, and usually the coordinate system looks like that. The top left corner has 0, 0 coordinate. X-axis is going to the right, from left to right, and y-axis is going from top to bottom. Keep it in mind, and if you want to know which coordinate is here, you can see how many pixels from the left and how many pixels from the top in this coordinate, and you will get the right value. And how do you connect OpenCV and Python, and with Python and ROS? There is an article called Working with Camera, and there is some information about how you can write programs for OpenCV. The example program is very, very basic. It actually doesn't do anything. It just makes, it just prepares image for you, and later on you can edit this image the way you want. Or you can detect some colors in this image or some shapes. But first thing, before we even try to open Edit Clover, is best to create another image topic with a slowed video stream, because camera has the like 40 frames per second, which is a lot. And if you just copy the code from this example, it subscribes to the topic image raw, and on each new frame, it will call the function that will perform some OpenCV on this image. And it is very heavy and CPU intensive process. You need to slow it down. And for that, instead of using main camera image raw topic, we will use another one that has much lower frame rate. To do this, if you scroll down in this article, you will find this line of code that you need to paste into main camera.launch file. So do that on Real Clover and on simulator, everywhere where you want to work with OpenCV in ROS. So I will do that now. I open up my virtual machine and find the file called mainCamera.launch. It is located in home, Catkin WS, src Clover launch, and here is the mainCamera.launch. You can open it and paste this line of code. So where do you paste it? I suggest you paste this line between these two lines. So let me copy this. So I press enter and Control V. Basically, this is one line, so you can put it in one line, but make sure you have a space after this throttle. And this is correct. Now you can save the file, Control S and close. Okay, what's next? So here we have edited our file, mainCamera.launch, and edit this line. And this example code will just allow us to work with OpenCV, but it will not actually do anything. So let's start doing things. First, what we can do is we need to change the color space. So you remember that we want to work in HSV instead of RGB. But by default, we will have BGR in OpenCV, which is not what we want to detect colors. Let's first see that we have this throttle topic. So here in browser, I go to localhost. Image topics, and yeah, as you can see, image raw throttle is here, and you will notice that it is slower. It has slower frame rate, and yeah, if everything is done correctly, it is working. So if you make some error in the file in the main camera.launch, there will be no any topics because there is an error that will block everything from working correctly. All right, let's find this code example. Remember, we have folder where all my codes are stored. This is the progs folder. I open it up again here, and let me close the programs that I don't need now. And let's create another one. Call it 3cv.py. 3 is just the number of programs that I have. So this is the third program. So it's called 3. And I will paste the code there. And let me explain a few things to you about this code. So first, we import ROSPy, and then we import CV2. We also import CVBridge, which is this is a Python module that will help you translate image from ROS to OpenCV and vice versa, so from OpenCV to ROS. This will allow you to connect these two separate packages together. Then you just need node the way you do it usually. The name of the node will be computer vision sample. It is fine, or you can change it if you want to. And then we will create a bridge object. So this is a bridge object. And we will call this bridge later. Then we'll define a function called image callback. I hope you're familiar with functions in programming and in Python. Function is just a piece of code with some parameters that you can call from wherever you want in your program and edit the parameters. So changing the parameters will change the output of the function or will change the effect this function does. So this function only does this, only creates CV image variable for you. So what is CV image? So their question is, can we do with block programming? Well, no, OpenCV is not yet in blocks, so maybe it will be added later, but for now it's only here in Python. Or you can try OpenCV with C++ as well, but I'm teaching you Python today. Okay, CV image is a new variable that we will get from this method. So here, bridge is an object, as I said, and this object has a method called imgmsg2cv2, which will translate the image message from ROS to CV2 format. And that's the format that we need now. Here, the first argument of this method is data, and the second one is BGR8. So data is the argument that is passed to image callback. We do not pass it manually. This argument is passed by subscriber. So this is like our image subscriber. and image subscriber will accept the image callback function as its argument, and it will call it whenever it wants to. So we will not worry about how to call this function anymore. We will just pass this function to image subscriber, and on each new frame, this function will be called. So whenever a new frame from camera arrives to the topic, image raw throttled, this function will be called, and data is actually the image itself. So the image that we got from camera is stored here in the data argument. All right, BGR8 is the color format that we get. And now we can do our changes with the image. First, let's convert the color space. So let's create this new variable image HSV equals, and here we can call CV2 function called CVT color. So CVT color, which is convert color. And the first argument here is the image that we want to convert from, which is CV image. And the second argument is the color space that we need. So I have copied the color from another file. So this is the color space that you paste. So cv2.color bgr2hsv. This is actually a constant that will tell OpenCV which color space we want to convert to which color space. So we convert BGR to HSV here. Okay, we have our new image. And now let's output the image, some pixels color. We want to output this color in console, in terminal. Oh, yes, hello.
Can you explain CV image once again?
I cannot hear you. Can you speak louder?
CV image equals to bridge. Yeah.
All right. So can I explain this?
Yeah, this one.
All right. I did it, but already, but I will explain it again. So again, bridge is the object that we will take like ROS image as input and output, well, and return the OpenCV image. Because so here is bridge, and it has the method called image SMG to CV2. This method will accept two arguments. First is the image in ROS format, and the second is the color format that we want to get. And it will return, which means that instead of this method here, a new variable, a new value will appear here, and we will assign this value to CV image. Well, CV image will contain a new matrix with colors. So this is just what we do. I hope you understand this, right? And then we create image as img as HSV, which is as an input we get CV image, this one, and we will get the same image but in different color space. And I want to show you the difference between the images. So basically these images are lists of lists, or maybe arrays of arrays, and you can get access to each pixel by index. For example, if I want to print the top left pixel of the image, I write print CV image, and here in squared braces I will first type the y coordinate, which is 0 in my case. And in the second pair of braces, I will write x. So here, y comes first. So y is the first value and x is the second. You need to remember that. It's a little bit different from what you used to be in coordinates, but just keep it in mind. And this will print the current color in top left corner of the image. Let's see. If we have the image where small black square on top left corner, and here we print this color. So image subscriber, this is also the object that will subscribe to our topic and call this function on each new frame. And rowspy spin will just keep this program without exit. So it will keep the program working without anything else. So it's just an infinite wait. I pressed Ctrl S and let's run. Let's check if there are some errors. No errors. As you can see, it is printing zeros. So it looks like a list that contains 3 numbers which are 0. And now if we take off we will see the values change. Here, as you can see, the top left corner will now have the value 120, 130 something, 150 something. This is B, G, R. So first is B, second is G, and the third is R. If we try to put a blue square in this point, let's check where we can do that. So sometimes it hits this blue color, and as you can see, it outputs 255.00. So now we know this is definitely BGR, blue, green, red. If it were red instead, it would be 0, 0, 255 instead.
And excuse me, I didn't understand. Why do we need to write data near the image callback?
Yeah, because this function needs to accept some arguments, because otherwise it wouldn't get any image at all. And, and data is just a random name. You can name it whatever you want. So the name of the argument is up to you. But here it is, it's called data. And when you pass this callback function to another, well, as an argument to this object constructor, this object will know that whenever a new image comes to this topic, it will call the function image callback, and it will pass the image to the first argument of this function. So instead of data, there will be image in the ROS message format.
I understand. Thank you very much.
Yes. Great. And this subscriber works on another thread. So you can keep coding, you can fly, you can do whatever you want in your main program. And on the background, there will be image subscriber working. All right. You output CV image, which is BGR. But what if we output both CV image and image HSV? So instead of CV image, I will type EMG HSV here. and the same values, 0, 0. Let's stop this program. So I click this window and press Ctrl C and run this program again. Now it will write two different lines at the same time. As you can see, they are different. They look not the same. Let me stop it here. So as you can see, if we see that 255.00 in BGR, it converts to 120, 255, 255 in HSV, which means that the hue of the color is 120. And saturation is 255, which is the highest saturation that you can get. And the value is 255. Now, these values are so extreme because we used very, very clear color here. And this color does not contain any, like, it's just super clear. You just do not have anything except blue here. And 120 is actually the angle at which blue color is there. You can find in this online color picker that if you type HSV of 120 and 255, so it's not even in the range of 255. It's here in the range of from 0 to 100. Well, and 120 doesn't look like blue. It looks like green. But what if we double the number? It would be 240. Well, it's not this what we wanted as well. So let's just wait a second. Hue 240. Yeah. And now we get this hue, saturation, and lightness of 50. Well, this is a different color space. It's HSL, which is hue, saturation, lightness. And this is HSV here, which is 240, 100%, 100%. So 100% is the same as 255 in OpenCV. And 240 is the same as 120 in HSV. Okay, I don't think this is the best color picker that we could select, but let's see what we have here. HSV, yeah. This is better. So instead of 360, we write 240, and we get our blue. Okay, let's go to the next part. What if we wanted to find the color of the center pixel instead of the top left pixel? So instead of this pixel, I will try to find the middle one. We need to type the correct X and Y value. Remember the resolution of the camera here. Well, the resolution here is 320 by 240. And which means that we have 320 pixels on the X axis and 240 on the Y axis. And for us to get the middle pixel, we need to divide these values by 2 and enter the corresponding values here. So in X, I will enter the half of 320, which is, well, 160. But it's better to type 159. And because the actual index of pixels starts with 0, not with 1. So we have pixels from 0 to 319. So here I typed 159 in X, which is the second order here, and the first order is Y. So Y is 240, which is from 0 to 119. 290, and now I will type from 0 to 239. Yeah, and here I will type 119, and I will copy the values from here to here. Now I will save it and run it again. All right, so you can see that sometimes it hits black, which is the arc markers black color, and sometimes it hits some other colors like white, and yeah, this is white. Okay, now we know how to output values, but we do not know yet how to work with these values. So let's open the article and find some cool stuff. All right, in this article, Computer Vision Basics, there is a thing called to debug image processing. You can publish a separate topic with the processed image, this one. And what's that? Well, we can create our own topic in the list of image topics. So here we will see another line with our topic with some additions or edits that we did with our color. Let's do that. So we need to create a publisher. Image pub equals ROSPy publisher. Here we type the name of this topic, and here we type the type of the topic. And we do that before our function. So image pub equals ROSPy publisher. The name of the program, I mean, the name of the topics, if it starts with tilde, it will contain computer vision sample in the front and then slash debug. We can avoid that by removing tilde and calling our topic the way we want. Just like that, for example. And here we need to publish some image in this topic. How do we do that? So image pub.publish, and here we need to call bridge again with CV2 to image SMG instead of img SMG to CV2. And here we will pass CV image and the color space. And we do that inside the function. So now here we have a publisher that will publish CV image with the corresponding color space. And let's save this and test if we have our new topic. So I will run the program. Okay, and update. We've got our new topic, and it just contains the same image that we got in image raw throttled. It's just identical because we do not do any changes in it. Okay. But what if we wanted to add some change and like add a circle or a square just on top of the image? Well, in OpenCV, you can look up online, like Python CV2 add circle, for example. And there is CV2 circle method. So you can look online, look up online for any reference. Okay, so this will image equals CV2 circle image center coordinates radius color thickness. So instead of names of the arguments, we can just pass numbers and tuples if we wanted to, and it will actually create a new image. So we can open our program and let's create a variable called like circle image equals, and here we go, CV2 circle and some parameters, which are center coordinates, radius, like image, center coordinates, radius, color, and thickness. Let's do that. So I want to see the reference on my left. All right, and first argument is our source image, which is CV image. Then we have center coordinates, and they are in, you need to open parentheses and close them because the type of this argument is tuple, and tuple counts in open parentheses, open and closed parentheses. So where do we put that? For example, in the same coordinates like here. But now we need to paste the coordinates x first, then y. So 159, 119. After this, we need to enter our radius, then color. So radius will be, let's do it a 5, then color. How do we enter color? It's just another tuple of 3 values, which is, I think is BGR, yeah, BGR. Let's create a red, or let's create yellow circle, which contains green and red without blue. So here's 0, 255, 255. The next one is thickness. Oh, let's have it 3 pixels. All right, and now instead of image, instead of CV image, we will publish circle image. All right, save it. And now let's test the program. As you can see, we get our yellow circle in the center of the image. Okay. Svetlana, are we going in time? Almost.
So Timofey, have you finished the first color recognition introduction?
Yeah, I think so.
Okay, good. So guys, do you have any questions? If you have questions, you can ask in the Zoom chat or by voice. Okay, if we have no questions, I would like to...
I have one question, sorry.
Yeah, great, great. Welcome.
Timofey, what's the site where you see the function of CV Sokol. Can you show
Again? What?
Yeah. What's the site where you see the function CV2 Sokol?
Okay, the website is. I can send you the link if you want. This is just first. I think it's just the first result in Google.
Okay. Yeah. I see. Thank you.
Yeah, here it is in the chat. But it's better to find the official documentation, which is docs OpenCV.org, and here there's drawing circle, drawing ellipse, a rectangle, polygon, and many more things. So I'll better send you this link.
Timothy, could you share this link into Telegram chat too, please?
Okay.
Okay, guys, any questions?
I haven't got any questions.
Okay, you can ask. Okay, guys, so I would like to remind you about our schedule for today. So we have past briefing, homework, and color recognition introduction now. Now we have a time for coffee break time. It will be held 10 minutes. Then we will start mini game. Don't be late, okay? So you can stay in the Zoom room right now. We don't break this room session, but we go to the break. Guys, we have 1 minute left before we start, before we continue our classes. Be ready. Okay, guys, so we have finished our coffee break time, and I hope you are ready to continue. So let's check. Let's check where are you. So please, if you're here and you are ready to continue, please write plus in the Zoom chat. Mikhail here, Sergey is here, or Salek's here. Kartik is here, Alexei, great, guys. So many of you is here, great, oh, great. Teams from India, Aush Kumar and Samyu Darshan here. Okay, great, I think we can continue. So and now we have a very interesting part of our classes. It's my favorite too. Elena has prepared for you interesting question about the materials that Timofey have told you before. So I hope you are ready to start it. Be prepared your laptop or phone for it. And Lena, welcome.
Thank you, Svetlana. It is better if you prepared your phone. And first question for you. Are you rested? I want to know how your mood is. Choose any reaction in Zoom. Okay. Great. And I share my screen. You know what to do. Please join at kahoot.it and enter game pin. We're waiting for you. Она есть.
7 attenders, 8 participants. Great. Okay, guys, we wait you in 2 or 3 minutes, I think.
Okay, 1 minute left before we start the Kahoot game. Oh, 15 participants. So it's really great, guys. Where is other half of our Zoom participants? Oh, Elena, we have increased the participants, 17. Okay, 1 minute left, especially for you guys. Okay, 20 seconds left. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, and let's start.
Yes, we can start. The first question is for logic. What image does OpenCV allow you to work with? Maybe you can guess. No, it is raster graphic. Okay. And second question. Okay, what is the y-axis direction is OpenCV? Okay, and one more difficult question. What about x-axis? Do you know? Okay, next question. What constant should you use to convert from BGR color space to HCV? Almost right. Okay. All right. Wow. And finally question, what is the callback function used for? Okay, are you ready? You know who won? Our podium, third place, Mikhail. Second place, Alexei. And first place, Vasya. Congratulations. You are great, guys.
Okay, guys. Thanks for participation in the Kahoot. We hope that it's really useful for you. So fourth place, as I remember, was by Vitaly, and the fifth place awarded to Ricky. Okay, guys, it's a really good result from 20 participants, as I remember. So now I think we are ready to continue our lesson. Now it will be work with the Clover Real drone. So Timofey, are you ready?
Yes, I'm ready.
Great. Guys, are you ready? We need your reaction and activity in the Zoom chat. So, okay, great. Ready, let's start. And welcome, Timofey. Let's start.
Yes, thank you. Now we need to learn how to recognize a certain color. And let me show it to you. So I've prepared this little piece of cloth for you. I will show you how to do that right now, so don't worry. I will show you how to place textures like that. It will simulate a real world colorful objects. So it's not so good to train with these pure colors. So you need to have something more difficult like this. Okay, let me show you how did I do that. Before I will return everything back to normal. Like that, okay. Now I have this texture on my computer. This is a PNG texture. Let's see, yeah, this is a PNG. So you need to make sure your textures are PNG. Yes, and I will drag this texture on to my virtual machine. And now I'm able to put this texture instead of some Aruko marker texture, like the markers that I put here, like the separate markers I put here, like this one. So let's go to Katkin, SRC Clover simulation models. And here is Aruko 200, the marker that I used from my markers pack, this one. And I will open it, and in materials, I open textures, put this texture here, and I need to first rename the original texture that contains Aruko marker texture, copy the name, edit the name. So I'll put underscore just before the name, so the system will not recognize this texture anymore. And now I will rename my texture and paste the name of this Aruko marker. All right, and now I already have this marker on my world. And if I open Gazebo, it will be there. Here you can see this marker. And even if I click insert here and open this Aruko marker 200, it will have the same texture, while the others will have normal texture. All right. So I will put this marker somewhere on the field, and we will start recognizing its color. All right. We have our program. Let's see, where is this? Yes. And all this program does for now is printing the color and creating a circle on the image. So I will not post circle for now. So I will comment out this line because I do not want to do this for now. And in Publisher, I will publish another thing, which is not here yet. So let me show you how to select color from a range of colors. All right. We need to first take off and find out what values our color has. So I will open the program. I will comment out the print CV image line because I don't want to print CV image pixels. I want to print AMG HSV pixels in the center. And I will take off and write down the values that my texture has. So I will put this texture under the drone. So it will take off and start writing the numbers. Here I'll type Commander takeoff. And let me run the program. Oh, look at this. I forgot. I need to comment the publisher as well. Okay, now I can run again. And as you can see, the values range from the hue is around 82 or 83. Oh, what's the, yes, it's around so it's around 82 or 83. The other values are saturation and value. Saturation is from, I think, 258 to 211, I guess. Well, it ranges much more than hue. And this is great because we want to have hue as narrow as possible. So hue distribution will be so narrow, and the others will have higher range. I can actually scale this texture, I guess. No, I cannot do that, unfortunately. Well, and so let me just wait a little bit more and I will stop this program. So these values are correct for now, and I will find the color in this within these ranges. Okay, so what do I do next? I need to create a separate a new variable that will contain newly processed image. So this image will be called, let me call it, what is this color of this image? Well, it looks like green, but we also have this type of green, which is another one. So I will call this green 2, and let me create a variable called green2 BW, stands for black and white, and it will be equal to the function called cv2.inRange. This function will accept 3 arguments. First is the source image. Oh, I think I ran over the wire of my headset. Yes. First is EMG HSV. Then I will need to provide a range for each color. Like for HSV, the minimum, and HSV maximum. Let's do this. It is also a tuple, so I will add a new parenthesis here. And the minimum H will be 80. 80. Then minimum saturation. I think it's gonna be 158. 158. And the minimum value is, I think it's 140, around 140. Or even 110. 110. Let it be 110. Okay, the next comma And another set of values are the maximum values. So it's 83, or let it be 84, just for adding one more extra level. Okay, 84, then the maximum saturation is, well, I see 211 here. Let it be 230. 230. Then what do we have here? The maximum is 207, I guess. Yeah, let it be 207. All right, so green BW. What InRange does, it will create a new image that will be made of black and white pixels. So black pixels will go instead of all the colors that do not meet my requirements. For example, if I wanted to find only the pixels with this color, all the rest of the image will turn black, and this part will turn white. This part will turn white, all right? And in my case, the color is this one. So on the picture, in this picture, everything goes black except for the middle part with this cloth. And this is stored in this green BW variable. And now I want to check whether my parameters are correct. And for this, I will put this image in my publisher. So I will uncomment the image pub, and instead of circle image, I will write green BW. And instead of BGR8, I'll need to type mono 8 because this color is monochrome. It doesn't have colors other than white and black. Well, mono 8 may contain all the shades of gray from 0 to 255. And let's save it and play the program. Okay, does it work? And as you can see, I think the values were quite good, but I'm flying way too high for this type of texture. I need to get lower. So here in navigate weight, or in navigate, just normal navigate, I will go to the coordinates 0, 0, and I think 0.7 would be fine.
Excuse me, and
Yeah.
could you share the program after this like lesson to we can look it better in our redactors?
Well, the program is for your homework, so I think it would be cheating if I send it to you as a
Okay.
file. So look at this. This is what I get, but some parts of the image are black, which I do not want to see. So as I can see, the darkest parts of the image are black, which means that we need to lower our value of lower the lowest value in our program. So here I have low value is 110, and let me do it 50, just 50. So in the best case scenario, there will be no longer black spots. Let's play this program. And here it's much better. Look, it's much better now. This is a good simulation of real world objects, but not perfect, because in real world, there's reflections and color and the lighting conditions. So many things may affect the color in pixels. which means that in real world, it's much harder to find the correct parameters for colors. And it takes like many times steps to to find the correct values for your color, but it's still possible to do. And what else do we need to know? For red color, it will be a little bit more difficult because a red color has hue of 0 or 179 as well. And it stands right in this extreme values. So for you to detect something red, it's better to create two separate color ranges and combine them together. So let me create another BW variable called red BW, red BW1 and red BW2, and they are equal to, I will copy this for now, and I will replace the values. So the first red BW will be minimum will be 0 and the maximum will be 3. All right, and I will also put maximum saturation and value to 255 because I think we have this red which has 255 saturation and value. Okay, and I will copy this here and create another. I will come to red from another side of the circle, which is, I think it is 176 to 179. Yeah, and the maximum go the same. So all the other parameters are the same as here, except for hue. And then I will create a red BW without number. And I will use CV2 bitwise or function. And this function will combine two images together. And if any of pixels with the same index are white, the resulting image pixel will be white. And if both pixels are black, the resulting pixel will be black. Well, if both are white, it's white. If one of them is white, it's white. And if both are black, it's black. So bitwise OR will do that for us. And I will enter two arguments, which is red BW1 and red BW2. And now I have red BW. This is the correct way of finding red color that's hue is very close to 0 or very close to 179. And this happens very often. So your red object may change its hue in this range, and you will need to know how to do that, how to deal with red. Okay, red BW is here, and I want to display this red BW in topic. Well, I think it's still posting the wrong color for me because, wait a second, it shouldn't do this. Red BW, red BW. Yeah, now it's better. I just needed to restart the program. And if I fly, if I land and take off again, and put my red, I see the red here. As you can see, it is working. So we can create any range for any color. And this is how we detect our colorful objects. But we need to not only detect them, but make some logic based on that. For example, I want to fly to a certain point, and if there is red color in this point, well, I can change the LED to red, for example. Or if it is blue, I can do another thing. Or if I do not know where my object is, I can detect where the white pixels of the corresponding PW variable are and find approximately its location. Okay, what can we do next? We need to do some kind of logic based on what we have now. And I will create this range for 3 colors. Let me see, what colors will I pick? I'll pick magenta. So magenta will go over there, for example. I will pick red. It's already there. And I will pick normal green, this one. So I will not detect this color anymore. So for these colors, I need to create the values. Let's see what color magenta is. Magenta is, well, let's start looking at it. Yeah, magenta has 150 hue. And now we can create a new variable for magenta. Magenta BW equals CV2. Well, I will just copy these values and so it's 150. I will do an average like 148 min and 152 max. So the minimum will go from, let it be from 60 and to 255 and 255. In simulator, these values are okay. In real world, of course, it will be different. So magenta BW. And now I have, I need to change the green so that the green is this green. Let me test the color of the green. Yeah, it has 60, hue of 60. And here I will use like 58 to 62 and 60 minimum and 255 max. Yeah, I have green and I will call it just normal green BW. So I have green BW, red BW, and magenta BW. Okay. How do I know if the color under the drone is one of those? Well, you can look up the pixel color of red BW and magenta BW and green BW. And if one of them is white, then this is the color that's under the draw. So here I need to add some logic. Logic like that. I need to create a variable called color. And this variable will be declared outside of this function. So I will create this variable. I can do it here. Color equals to undefined. So it's just, we do not know what the color is, undefined. And in image callback, I will create a global variable. I mean, I will use the variable color from a global scope, from the global scope of my program. And I need to do that because I want to access color variable outside of image callback function. But by default, if I use just color variable inside the function, it will not be available for me from outside of the function, like if I want to test what color is somewhere in the program. This is why I need to write global color. Global color, yeah. So global is a keyword that will tell that the color function is from global scope, and if we edit color function inside, I mean color variable inside our function, it will edit it in global scope as well. All right. Now we will create some if statement. If red underscore BW. And what do you type next? You remember, if we want to access the value of the color in the image here, we need to type X and Y in squared braces. So this is the center of our color of our image. And if it equals 2, so there's a double equal sign. If it equals to 255, so color is red. Color equals red. Then elif green BW equals the same thing. Color equals green. Elif magenta BW equals 255. Color equals magenta. Else, if none of those is 255, color equals undefined. Okay, and now in our program, we can get access to the color that's drone is hovering over right now. How do we do that? Okay, let's see. We have this color, this image callback. Yeah, subscriber. And after the subscriber, we can, instead of for spy spin, we can just create a loop that will print the color like once in a second, for example. So the correct way to write loops in rows when you are working with rows is to write while not row spy is shut down. Oh, sorry, row spy is shut down. And this is just for making sure you will not stuck with the program working and without being able to stop it. So don't try to grasp it if you don't know ROS. Just remember this is the way to create infinite loops in ROS. While not ROS.py is shut down, print color and ROS.py sleep 1 second. Okay, this is the program that we can test. So I removed ROS.py spin because if I have something else that will keep the program working, I do not need it anymore. Yeah, it's writing undefined and it's writing all these pixel colors. So I will stop the program for now, just to delete or to comment the print function. Okay, and now let's check. Undefined, undefined. But what is the color actually? It should be something other than undefined. I think it should be green. Oh yeah, it's green sometimes. And the other times it's undefined. Sure. And let me put magenta under the drone and get away. Put the green away. Yeah, it's magenta. And let's check it with red. And now it's red. But still, this program does not make drone to take off. It doesn't control the drone's flight. So this is what we just need to add right now. Let's bring it down, Commander Land. And I will put all the colors to certain points, maybe here, here, and here. So I'll remove other colors that are not there. So the colors have coordinates. You can find the coordinate of an object in Gazebo by clicking the object and opening the pose on the left menu. So X is around 0 and Y is around 2.5 meters of the red color. And magenta has 2.8 and 2.5. Green has 2.8 and 0. Okay, and now I will populate the program with flight logic. How do I do that? Let's first open the let's open our COEX Clover COEX stack with the article simple offboard will work. So let's open simple offboard and find what we need to add to be able to fly. So we need to import Clover from Clover import SRV and from std import trigger. Let's see if we do not have that. No, we do not have that in our program. So I will copy these lines and paste here from Clover import SRV from std service import trigger. Then after our spy init node, I need to add some service proxy. Those service proxy. Okay, now I'm ready to fly. But one more thing I want to add here is I want to add a function called navigate weight, because this function makes it much easier to write programs where you fly. And this is the first code snippet in the code snippets article. So fly it toward a point and wait for copter's arrival. So this is the function, and this is the module that you need to import for it to work. But there is actually a way to avoid importing math. I will not show it to you right now. I'll just tell you that you can, instead of math SQRT here, you can remove it from math SQRT and just use tolerance to the power of 2, like that. And this will return you the same results. Anyway, for now, I will just copy this function and paste this function right under the def image callback function. So this is where my image callback function ends. On the next few lines, I will add the navigate wait, and I also added the default values. So z would be 1 point, well, just 1. Yaw equals 0, speed equals 1, and frame ID equals argmap. Okay, and my navigate wait function is ready to work. And to fly to a certain point, I will call this function with parameters that I need. Okay, while not ROSPY is shut down, I don't need here this loop, but as you can see, navigate wait also has while not ROSPY is shut down. So this is just the basic way of doing infinite loops in ROS. I have told many times about navigate wait, so you can find, if you do not know how it works, you can find it in my previous lectures. And I will take off by calling navigate wait with the values of, well, I only need to change frame ID equals body, and auto arm equals true, because I want to arm the drone. Very important thing, if you don't know how to program Clover, you should only put auto arm to true when you take off. All the other cases never use auto arm true because it's very dangerous. It may cause losing control of the drone if you want to take the control with the controller. So please just use it once when you take off, or if you take off several times in your program, use it several times, but never after that. Okay, it takes off. Then you do not need to wait any time, because this function will wait for you just the time that needed to take off. And you can call another navigate wait. Now I will go to the coordinates 0x and 2.5y. Then I'll need to go to 2.8 and 2.5. I guess this is the correct coordinate. Let me check. Yeah, that's correct. Then I will go to 2.8 and 0. 2.8 and 0. And then navigate wait with empty parentheses. We'll go to 0, 0, because 0, 0 are default values for navigate wait. And now land. We can test this program, but it doesn't do anything yet. We want to actually print, after we reach each point, we want to print color. So I will copy and paste print color in every point. And let's test this out. I think I forgot to save this, and I need to run it again. Oh yeah, I forgot to import math, just what I told you about. on top of the program, just write import math. And now I can play this program again. Yeah, it's going to the first point. It missed the point. Oh, okay. Next point is magenta, which is correct. Yeah, I will run this program again because I want the first point also to be detected. Red, magenta, and green. Okay, and you can even, this program still does post the image in the topic, and the image is, where is this? It's red BW, so when it's red, you can see it in the topic. Let's check. Yeah, you can see it's coming to red. And it's going away. And what we want to do now is to do this thing on a real drone. This is why I'm going to stop this simulator for now. And let's find our program. I will modify it a little bit. So on our real field, we do not have magenta and we do not have green, but we have red, blue, and yellow. For now, we will only detect two colors. Let it be blue and yellow. Yes. So on the real field, we have red, yellow, and blue. So we will detect these two colors, or maybe just one, because it might take some time to find the correct values. And so for now, I will comment these lines. Instead of green, I will write blue. The values will be changed, so I will not touch them for now. Instead of magenta, I will type yellow. And here, I will say blue and yellow. I remove magenta. Yeah, that's better. Yeah, and here instead of printing red, I will print blue for now. Blue, BW. And I don't want to fly, so I will comment all the flight functions, I mean, on the flight logics, and write rospy spin here. Yes, and also I want to display the EMG HSV. So I will uncomment the print EMG HSV. Okay. So it's for blue now. I will detect blue color. And yeah, I think this is it. And I'm ready to test it on a real drone. Можешь дрон сейчас включить? Yes. So I'll copy this code from virtual machine. Батарейку надо другую. Yeah. And then I will connect via Wi-Fi to the drone. Включи сразу. Yes, let's wait for the Wi-Fi network. Yeah, the Wi-Fi is here. I'm connecting. Пока просто положи и сейчас сделаем. Yeah, so the drone is working and the Wi-Fi is working. Now I will copy my program and I will paste this program. In web terminal. The password is Raspberry and nano2.py. Control-Shift-V. Yes. I will double check if there is nothing to fly because I do not want to fly now. Okay, and Control-S, Control-X. Oh, one more thing we forgot. We need to add the line for creating the image raw throttle. So I will add this line here. CD Katkin SRC Clover launch, nano main camera launch. And here on the bottom, I'll paste this line like that. And sudo systemctl restart Clover is the command to restart Clover system. And I will go back to the home directory, wait for the new topic to appear. It's yeah, it's here. Image raw throttle is working great. Can you pick up the drone over the blue marker? Okay, the hue is 99. So the drone is over the blue marker. Hue is 99. Saturation is 255 and value is around 137, which is great. We now can, yeah, you can put it down for now and we will use the values to edit our program. So 99, 255 and 137. Okay, blue low. We will go from, I think, 98 to 100. And this 250, maybe 250, and the max is 255. Okay, and the minimum value is 130, I guess, and the maximum is 142, 45, like that. Yes. All right. And we will, what will be in our topic? Yeah, blue. Great. Control S, Control X. And now we can test the program again. Can you pick up the drone? Let's go and test our topic. Svetlana, can you put it up to the height of 1 meter? Yes, it is detecting this image. Let me also compare it to image raw throttled. Yeah, there are some patches that go off, but we need to find out why. They are either too bright or too dark. Well, anyway, thank you. You can put it down for now. We will test. We will increase the values a little bit so we can be sure everything goes in. So in 95, from 95 to 104, then from 240 to 255, and from 125 to 150. Поднимешь опять? Yeah, now it's much better. As you can see, it's a great square. Well, some of them, of the pixels are still sometimes off, but anyway, it's mostly working properly. Okay, now can you put it to the yellow, over the yellow one? Okay, yellow has these values. Let me stop this program. Thank you, put it down. And yellow has range from 23 to 26. Yeah, it's so ranging from 23 to 26. Let's edit the program. Okay, and the rest are 205, 158. Okay, now let's okay, yellow minimum goes in one, no, it's 20, let it be 22 and 29 or 28. Okay. The second was, again, it's about 120, from 120 to 220. Save, and the final is from, I think it's from 107 to 160. Okay, let's test it again, but I also need to change the image here, the image that we put to topic. Instead of blue, I'll put yellow. Svetlana, can you put up the drone? Yellow. Yes, and let's see. Can you put it higher? Yes. So there is another marker, but it is not as bright. And I think here we need to change the saturation. So this marker is probably lower saturation. And I will quickly edit the saturation and test again. You can put it down for now, and soon we will test it again. So saturation, because it was more close to gray. So okay, yellow saturation. Yeah, from 120, let it be from 80 to 220. Okay, can you put it up again? I think a little bit higher. Well, it's better, but still on the lower. Can you put it lower? Yeah, sometimes it's not detecting this color correctly. Well, anyway, it's best for us to okay, thank you. Put it down. It's detecting color pretty well under the draw. And I saw some of the colors were missing from the center here. What is wrong with them? 206, 150. Yeah, I will just increase just a little bit all the parameters for yellow because I want most of them to fit. So I will decrease the minimum ones and increase the maximum. Sometimes it's okay to have very high values. Control S. Can you test it again, Svetlana? Yes. Yeah, now it's much better. It is much better than before. Okay, thank you. Put it down. And now we will create a program that will fly over certain points. We need to find out what are the coordinates. What are the coordinates of our markers? So this one is definitely 0 in Y direction, in Y axis, and 35 in X. Yeah, we can also check the coordinates with our service, with the get telemetry service. I will show you how to do that. So wait a second, I will open up terminal. So there is a service called get telemetry. I press tab in the end, and here in frame ID I will type Aruco map. Okay, and now let me just yes, you can put the drone up over the closest yellow. I will press enter and we get the telemetry of the drone. X is 0.26, Y is 0, and Z is 1. Okay, thank you. Go to the blue one. And arrow up and enter. And this get telemetry returned 0.28x and 2 meters in Y. Okay. I think this is enough for us. Thank you. And we will use these coordinates in our code. So X is about 30 centimeters, just as I told. Well, to be clear, it has to be 35 because distance between this center and this center is 70 centimeters exactly. So here will be 0.35 and this is 0 in y-axis and this is 2 in y-axis. Okay, let me edit my program. I will uncomment some lines. Okay, first navigate is for taking off. This is correct. Then we will go to the 0.35 and 0. The second 0 we can just avoid. Well, we can say just 0.35, print color, and then navigate to 0.35 and 2 meters, print color, then we will land. All the commented lines won't be executed. Okay, save. Can you give me the remote controller of the drone? Thanks. Я вижу. All right, and okay. So the program is flying to over this marker, print its color, and then flying over this marker and print its color. As I told you, I need to put the throttle stick on the left. Yeah, I need to put throttle stick in the middle and the SWC stick in the lowest position. And if I want to take the control, I will put the SW stick up, and now I'm controlling the drone. All right, let me share the screen again. Python 2 and get ready. 3, 2, 1, go.
Let's fly.
Well, I think it's not taking off for some reason. Let's stop this program for now. Oops. Yeah, some problem occurred. Let's check this out. Yeah, as you can see, I just pressed kill switch, and the drone is still armed, which means that if I release kill switch now, it will fly to the sky, which is not what I want. So in this case, I need to take the control by switching the flight mode to stabilize and disarm the drone like that. And then I will test kill switch for just a fraction of a second like that. If it didn't turn the motors on, then this is fine. So I can release kill switch now. All right, let's see what's going on in the program. Maybe there is an error. Okay. I'll share the screen. Okay, let's see. So navigate, wait. Oh, because I forgot to remove ROSPICE pin. Yeah, this is the reason. Always remove it if you want to fly. Now Control S, Control X. And again, the same. Okay, ready, steady, go.
Let's fly.
Yeah. Oh, it says it's green. It's because I forgot. Yeah. And on the last position, it's just undefined. Okay, there's a couple more bugs in the program. First is I forgot to change the color name when it should be yellow, it says it's green. All right. Another bug is if I want to return to the 0, the coordinate 0 before I land. And the third thing to change is I want just to hover for a second over the color before I test the color. So after navigate wait, I will go to and go and write spy sleep 1 second. Yeah, and I can Control K and Control U to cut and paste lines in Nano. So I pressed Control K and Control U. Then I can press Control U again here, and then navigate wait and land. Save it, exit. And we're ready to test the program again. Oh, one more thing is I will remove printing the current color here. So we will only see the output in console. Are you ready? Let me change the screen view. Yeah, the drone is a little bit, it's not horizontal, but it's okay, it will take off. Oops, a little problem because I think it's because it wasn't horizontal. Let me test how it flies in position. Yeah, it's fine. Almost. Okay. Yeah, no, this is not totally fine. Can you bring the drone to me? Yeah, someone. Yeah, we'll need to restart it because it didn't behave so well. Лена, поставишь? Yeah, after restarting the drone, we will connect again. And I will also do some checks before I take off and show you what you can look at when trying to debug the drone. Okay, the first is ROS run Clover self-tab self-check.py. And this program will test multiple systems, and if there are some errors, okay, let me run it again on the big screen. No, wait a second. I will just try to figure out what's going on. rangefinder. I think the rangefinder maybe not working. Let's cross topic echo / rangefinder / range. No, it's working. I will test the drone in manual flight mode and in position flight mode. Well, the battery is low, but it's enough for one flight, which is okay. And we can make sure the battery is enough by connecting with ground control. So this is ground control. We can create a COM link. So for doing this, press this purple button, COM link, add, type TCP, and host address is the Clover IP. Select and connect. Yeah, it has some battery, which is all right. So it's 15.9, it's okay. One more thing, I wanted to change a value of in parameters, multi-copter position control and MPC thrust hover. So this is the value of the thrust that's needed for hovering. On 4S battery is around 38%, so I just save it. It will make the drone fly a little bit better in autonomous flight mode. Okay. And now I will run the program again. Okay, ready, go. Yellow and still undefined. Well, for some reason, it's not detecting the last color. Maybe it's flying too far, or maybe there is some other reason. Let's see what it shows in the topic. Or Svetlana, do you have more time? If not, we can just stop it for now. Okay, yeah. Well, anyway, one of the color is recognized. Another one is also recognizing, but not currently. And we can easily fix this problem if we dig more. But we do not have any more time, so I will give a word to Svetlana. So thank you.
Okay, thank you, Timofey. Guys, how are you? Are you here? So please write something into Zoom chat.
Yes,
yeah, great. Yeah, Timofey today showed us many important things, and I suggest that one of the most useful things, it's demonstrated problems and solving of and suggested solution of this problem, because when you try to perform any task, you will find or you have many problems during this task. Yeah, and it is really great when we demonstrated you some problems and suggest you solution of it. But unfortunately today we don't have enough time for it, but we continue tomorrow and you will get all answers on it. So now I would like to finish our day with you. But before it, now is the time for feedback. And when we finish the feedback, we will continue and share with you your homework, of course. Okay, so let me welcome Elena. Elena, she has prepared for you. Interesting questions. So it will be provided in the new service. Elena, please tell us about this service. So how it works.
Sure. New day, new questions for feedback. You know the service before, because yesterday you did it. In this, you should join to menti.com and enter code you see in the screen. And now you can do it.
Yeah, guys, for your convenience, I have shared the link with you. So please enter the code that you have seen on your screen. Okay, and we wait 2 minutes while you answer on this question, because it's really important for us to get a feedback from you.
I saw your reaction. It's cool.
Okay.
Okay, so 30 seconds left and we will go to the next question. So now we have in the leader color recognition. Yeah, it's the most interesting and useful topic. Okay, on the second the second place goes to the copter flights and mini game, of course. Yeah, and the third place. Great. Guys, your reaction is awesome.
And next question for you. Please write your wishes and suggestions.
Yeah, guys, we are really, for us, it's really interesting to know your opinions, and maybe during the previous day and for today, you have any suggestions how we can improve, and maybe we can try to apply your suggestions on the next days. More mini game. Wake up. Unfortunately, we cannot provide wake up, you guys. Okay, how to debug the problems? Oh, debugging of the problems will be tomorrow too, and the last day, of course. More code examples. Oh, interesting. So what are the topic of the code examples do you need? So what will be interesting area for you in the code examples? Oh, nice teacher. It's so cute. More drone flying, yes. Longer coffee breaks. Oh, guys, if we provide longer coffee breaks, we cannot to give you more useful information because we have only 3 hours in online. It's not easy. Great, great. Okay, thank you for your feedback. Okay, and the last question, Lena.
Yes, last question for you. What was the most difficult for you? Please write to Zoom chat. Oh, I see the comments. Your reaction is the best.
Okay, the most difficult for many of you it's mooring and color recognition code debugging and color recognition process. Yes, it's you are really you are right because color recognition it's really difficult topic and Timofey has prepared for you really good lessons because this information you cannot find anything. Yeah. So okay, thank you all. Thank you for your feedback. We will repeat these steps tomorrow too. But now the one of the most part of our camp. Okay, so Nikita has prepared for you the homework. Nikita, welcome.
Yeah,
Thank you, Elena, for this feedback. Yeah.
good afternoon to all of you. I hope you have enjoyed today's meeting, today's seminar, and you have understood everything Timothy was talking about. I really hope that you will be able to complete our home task. So some words about this. To this picture, I was inspired to play this picture when we have checked your home task during this morning. So yes, the first step, as a rule, as always, to install the new world in your Gazebo simulator with the color markers. We are now constructing it, and Timothy will send this world to our Telegram chat really soon, and you will be able to download and install it into your Gazebo world. The second is to run the color recognition code to check if it works. So
Nikita, one moment. How about letting you create your own world? Because I showed you how to create the world, and you already have markers. I gave you the models. So you need to create, to put markers to the world and save it.
Anyway, if no one has doubts and if they have skills and opportunity to do it, no problem. Of course, it would be a great training, the skill training about the Gazebo world creation. I have no doubts about this. So yes, I accept it. For me, okay. So the first step, do not check, do not install. You have to create your new world.
Nikita, we have lost you. some technical problem, I suggest. I hope Nikita come back to us. So as you understand, you should to create the Gazebo world by itself. Guys, I hope you are ready for it. Of course, I believe in you. We have a question in our Zoom chat. What world parameters? Timofey, could you help us in this question?
I'm back. Can you see me? Can you hear me? Everything is okay?
Now it's okay.
Oh, I'm really sorry. Something happened with my network connection. It was really amazing for me also. I haven't expected this. So once again, my demonstration. Wait a moment. Okay. So as I have already started to talk, your flight task consists of some points. First of all, you have to take off. Then you have to fly to your color marker. Here I have one, and you will have two. So this is just an example, not the real task. And after that, you have to print in your web terminal butterfly. You have to print which color you have recognized. It can be yellow or blue. So do not forget to make this point. And after this, you have to land. I think that you are able to land anywhere you want. You don't have to return to the takeoff point. You can land on the color point or somewhere nearby. No, for me, that is no problem, I think. So that is all from me. That is everything about your task. If you have some questions, please, you're welcome to ask me right now, and I will be able to answer them.
We have a question in our Zoom chat about what world parameters, what's map size. So we suggest that we have the same Aruka map, yes?
Of course we have the same. That is why we have given you the task to implement the ready-made Aruka map in your Gazebo simulator. We have done it for all for all 4 days of our training. We will use this map. We will just modify it with some color markers. You understand me? So yes, you are able to use the same word. You can place the color marker anywhere you want. You can place it nearby the takeoff point. You can place it on the edge of this point. No doubt to me.
Yeah, okay, great. And also was a question about 1 or 2 markers, as Timofey demonstrated to you to how to recognize 2 color markers. Yes, we give you the difficult homework. It means that you should recognize 2 color markers.
So as I have already told, this task I have shown you, it is just an example how to do it. That is your steps, yes, what you have to do. Just an example, you have to add 1 more color marker. So you fly to first marker, print result in your terminal, fly to the second one, and also print result in your terminal. And just after that, you have to land. Do not forget about the second one. So is it everything about the questions? Svetlana?
Yes, we don't have any questions. There is no questions. So it is mean that you can continue make a questions into Zoom, into Telegram group. Yeah. But now, before we finish our meeting, I would like to remind you about our tomorrow schedule. So let me share my screen. Yeah. Okay, so today we have passed the today you have learned differences between simulator and the real drone, and tomorrow will be color recognition, deep learning. You will learn how to recognize red color and more, and how to apply it on real drone. Also, we will fix all problem, and of course we will demonstrate you how it works. And on tomorrow you will get the main task, and this task we will work on this task 2 days, tomorrow and after tomorrow. Okay, now maybe you have any questions, and before we finish I would like to ask you, please turn on your cameras, guys. We would like to see your tired faces. Okay, great. So many of you turned on the cameras. Great. Nice to see you guys. Oh, you all have a smile. Smiles are really good. Okay, great. So also I have one news for you. It is our small surprise. So for this surprise, I need your support. So please turn on your cameras. Yeah, so we have a really interesting and positive news for you. So today is 19 May. It's today is the birthday of Elena Silverstova, our trainer. So please support us and say congratulations to Lena. Please unmute your microphone and say happy birthday together, guys. I need your help. So it will be really great gift for her. Yes, Elena. Yeah.
Lena, happy birthday!
Happy birthday, Leona.
Happy
3,
birthday.
2, 1, happy birthday!
Happy birthday.
Lena,生日快乐 birthday.
Great. It's a really great international happy birthday, Lena.
Thank you very much. I'm happy.
Birthday gift.
It's better than gifts. Oh, great, Lena. We wish you many interesting projects and be successfully in all business deals. Great. Yeah, some hurts for Lena. Guys, thank you all. So we are ready to finish our meeting, and before we finish, I would like to say many thanks to Lena for your support, for your preparation of feedback and mini games that you like it. Thanks, Nikita, for preparing homework, and of course the biggest thanks to Timofey Kondratiev. He trained you and he explained you the simple words, the really difficult topics. It's really awesome, Timofey. Thank you.
Thank you.
Okay, guys, now if you don't have any questions, we can say goodbye and finish our meeting for today.
Thank you, Sakhalin, for organization this event.
Thank you. We like to
Thank
say
you very much.
Thank you together. Yeah.
Thank you very much. Goodbye.
Bye. See you tomorrow.
Bye.
Thank you.
Bye.
До свидания.
Пока.
С днем рождения, Лена. На русском.
Thank you.